Hi everyone, welcome back to another video of CambiHub, and in today's video we are going to cover IGCSE Computer Science February-March 2024 paper, and we are going to solve it. Right, so starting with the first question of the paper, says computers represent different types of data in binary. So they're talking about binary. We know binary is a base 2 number system as it includes numbers 1 and 0. First option says computers, okay, the question says take one box to show the reason why computers use binary to represent data. First part says computers only allow ones and zeros to be entered. That is not true, because we also have other number systems such as hexadecimal and denary. Both computers and humans can quickly process data. That is also not true, because we have high level languages which are close to English terms and hence makes it easier for humans to understand. Makes it better for humans to understand. Binary does not need to be converted into other forms of data to be displayed, which is also not true. So by the method of elimination, the correct answer is this. However, let's read the answer. Computers are made up of switches and gates that can only be turned on and off. So we have logic gates in our computers, right? Remember chapter 1. These logic gates can only be on or they can only be off, right? And on is 1 and off is 0. That's why they use binary. Okay. Now they're saying that we are using ASCII, which is American Standard Code for Information Exchange. It's a character set. Now they're saying that this character set has n, right? N is the number that is given to us. And what is n? What does n have? Okay. N has the number 78. Now we need to find the number for Q, right? So if A, B, C, D, E, F, I, J, K, L, M, N, N is 78, O is 79, P, Q, 80, Q is 81. Hence, the correct answer for this is 81. Now, we need to convert 81 ASCII denary number for N. So, what we need to do is we need to convert denary to binary. We have this 81 number, we need to convert this to binary. So, let's start. We have 81, we need to convert this to binary. So, 2 divided by 80, we have 40 here, right? 80, so 80, sorry, we'll get the remainder to be 0. However, this is 81, so when I divide it by 80 by 40, I get a remainder of 1, right? I get a remainder of 1. Then I'll divide this by 2. Again, I'll get 20, remainder will be 0. 2 tens are 20, remainder will again be 0. 2 5s are 10, remainder is again 0. 2 2s are 4, remainder is 1. 2 1s are 2, remainder is again 0. So we move this direction. So we have 1 0 1 0 0 0 1 1 0 0 1 1 1 1 0. Okay, now they're asking for N. We have done for Q. So this is not we have to do, right? Sorry, it's my bad. I just need to do it once again. Okay, we'll start the recording with starting. Hi everyone, welcome back to another video of CambiHub, and in today's video we're going to do IGCSE Computer Science February-March 2024 paper 12. Starting with the first question says computers represent different types of data in binary. Take one box to show the reason why computers use binary to represent data. So we need to take a box to show that why do computers use binary to represent data. So first option says computers only allow ones and zeros to be entered, which is wrong. Right? We also have other number systems which are hexadecimal and denary, which we have studied in chapter 1. Computers are made up of switches and gates that can only be on and off. Yes, computers are made up of logic gates, right? And as we studied in chapter number 10, that logic gates can only be true or false, or they can only be on and off. On is 1 and off is 0. So this makes sense, could be the answer. Binary does not need to be converted into other forms of data to be displayed. This is wrong, right? We humans, we need it. We understand high level language. So it is either converted to text or high level language for us to understand, and both computers and humans can quickly process binary data. No, humans cannot quickly process binary data, right? Because a combination of 1 and zeros is kind of hard for us to understand. Moving on to the next question. Next question says that the ASCII, now we are using the American Standard Code for Information Interchange, which is a character set. ASCII uses N, right? And N is 78. Now we need to take out the ASCII equivalent of Q. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q. So if N is 78, A, B, C, D, F, G, N, O, P, Q. So if N is 78, O is going to be 79, Q is going to be 80, and P is going to be 80, and Q is going to be 81. So the correct answer is 81, right? Moving on to the next question. Now it says gives the binary equivalent ASCII for denary number of n. Now see, this is where they are confusing you. Here they have asked for Q. A lot of students after reading this will write the binary equivalent for Q. But then we have to write the binary equivalent for n, which is 78. So let's convert 78 to binary, right? We do the prime factorization method, right? So dividing 2 by 78, 2 3s are 6, 1, 8. So 2 9s are 18. So 39 remainder will be 0, 2. Let's divide 38 by 2. 2 1s are 2, 1, 18, 2, 9s are 18. So 19 again, remainder 0. 2, 9s are 18, remainder 1. 2, 4s are 8, remainder 1. 2 2s are 4, remainder 0. And 2 1s are 2, remainder 0. So 1 0 0 1 1 1 0, right? This is going to be 1. Okay, I have done a mistake here. Right, let's convert for 78 once again. Right, 2, 78, 2 3s are 6. Right, 1, 8, 2, 9s are 18. So 39, remainder is 0. 2, 39, 1s are 2, minus 1, 19, 2, 9s are 18, remainder 1. So 19, remainder is going to be 1. Then 2, 9s are 18, again remainder is going to be 1. 2 4s are 8, again remainder is going to be 1. 2 2s are 4, again remainder is going to be 0 now. 2 1s are 2, remainder is going to be 0. So our answer will be 1 0 0 1 1 1 0. So we move in this direction. So 1 0 0 1 1 1 0. However, this is 1 2 3 4 5 6 7 bits. We have to make it 8 bits. This is the correct answer. Now the next part says explain how the word red is represented using a character sets, right? So how is that? First of all, each character has a unique binary value. So RED, each character is going to have a unique binary value. Then RED, this RED is going to be stored in a sequence. So the binary value will be stored in a sequence. So first it will store for R, then it will store for E, then it will store for D, right? So first it will store for R, then E, then D, right? Okay, moving on to the next question. Explain why recording sound with a higher sampling resolution creates a more accurate recording, right? So first thing you are going to explain is that more bits will be allocated to each amplitude. So you will say that more bits will be given to each amplitude, right? So this is the sound wave, right? This is our sound wave. It's a longitudinal wave. This is called the amplitude, and amplitude is directly related to loudness, right? So you're going to say that more bits will be given to amplitudes, right? Making them more precise, right? Once you have explained what is going to happen, now you're going to tell that what will be the benefit, right? So first benefit will be, it will record more dynamic range. So there will be more dynamic range, and the sound will be louder. Now the next question says, give another way to increase the accuracy of a sound recording. So to increase an accuracy of a sound recording, another way is the sample rate, or you can say increasing the sample rate. Moving on to the next question. Next question is from chapter 3 hardware. It says a computer has a CPU, it has MAR, MDR, ACC and CIR. So they have given you registers, they have given you program counter and accumulator. Okay, so all three are registers, right? So you need to insert the statement in correct order. Okay, no, so you need to specify which is the incorrect statement, right? So first, program counter stores the address of the next instruction to be assessed, which is true. MDR stores the instruction of the program that is running. No, MBR doesn't store the instructions. CIR stores the instructions, right? MDR stores the data that has to be passed to the program counter. No, MDR does that. Oh, no. So MDR does that, but MDR stores the data that is passed to it from PC. No, the data is not passed to it from PC, right? It is from MAR to the PC. Then ACC stores the result of each calculation, which is yes. CIR stores instruction currently being executed, yes. So our first incorrect statement is B, and the correct statement for this will be that MAR stores the address and not the instruction. So you will say that MAR stores address, not instructions, right? Or you can write it vice versa, that CIR stores the instructions of the program, right? Not MAR. Then the correct option will be option C. Incorrect option will be option C, and the explanation for this will be data is from address in MAR and not PC. And not PC. Okay, now it says state what is meant by 3.5 GHz processor. So we know 3.5 GHz means that the processor can process 3.5 billion fetch, decode, execute cycles in per unit time, and that will be 1 second, right? That will be 1 second. Now the CPU is changed to be dual core 3.5 GHz. Explain how the number of cores affects the performance of the CPU. So we know each core contains an ALU, CU and other components, right? So what will happen if I increase the number of cores in a CPU? First point, you will say that increasing the cores will increase performance. Why? Because if we increase performance, the load of each core, right, the workload of each core will be divided into more cores, hence it will increase the performance. Then, right, it will allow more fetch, decode, execute cycles to be processed, right? It will allow more fetch, decode, execute cycles to be processed, right? Why? Because cores will divide the workload and they will process an instruction simultaneously at the same time. Okay, next question. Explain how the amount of cache affects the performance of the CPU. Right, first of all, you will say that cache is a temporary memory to aid CPU's tasks, right? Or you can say to aid CPU, right? Increasing the cache will improve performance, right? You will write increasing the cache will improve performance, right? Third point, instead of having to access the data from a RAM, a slower RAM, increasing the cache will increase the performance, right? Why it will increase the performance? Because more cache means that the processor can access more frequent data. So if the cache is increased, processor can access data frequently, more frequently than a slower access DRAM, or you can simply say a RAM, right? Okay, describe what is meant by RAM. So whenever they ask you these kind of things, right, random access memory, you will first describe that what the thing actually is, and then you also need to give a few features of it, right? It is not always mentioned in the question, but then again they use these things to trick you. So you are going to say that RAM is random access memory, which is a volatile storage, right? RAM is volatile storage. It can be erased, it can be, right? Then it is directly accessed by the CPU, right? Because it is with the CPU, so CPU has direct access to it, so directly accessed by the CPU, right? Then you are going to say stores currently running applications, right, data or instructions, right? Okay, identify one other item of data that is commonly stored in ROM. So ROM stores startup instructions, right? Now they are asking you to state another form of data that the ROM stores. So we all know that the basic input output system, or the BIOS, is also stored by ROM. Instead of BIOS, you can also say bootstrap loader, right? Or you can obviously mention firmware or any part of the operating system. However, BIOS is the best option, and you should put this point on priority. Okay, what is the purpose of virtual memory? So we all know virtual memory is when RAM is full, right? So what is the purpose of virtual memory? To run programs when RAM is full, right? Okay, now they're asking you the function name and the description. So what is managing memory, right? So you are going to say that managing memory is a process which allocates memory. So allocation of memory to processes, right? This is what memory management is, and also it will prevent two processes to access the same memory so that the system doesn't crash, right? Okay, allows application software to run on computer. What allows application software to run on computer? Platform for running applications. So you're going to write platform for running application. Okay, what is managing peripherals? My peripherals are any output devices that we put, right? Suppose a USB. It can also be a camera, a webcam, right? So any external device we connect to the computer is peripheral. So what is management of peripherals? You are going to mention the drivers. So first of all, you're going to say allocates data to buffers. This is generally in the case of printers, right? This is generally in the case of printers. Then you're also going to say transmits data to hardware. It will transmit data to hardware. Then it will also receive data from the hardware. And then the last point will be automatic driver management. Okay. Now state the purpose of an interrupt. Right. So interrupt is to indicate the processor a high priority task. Right. Identify one input device and one input device and one example of an interrupt it can generate. So you can also say a mouse, right? You can say a mouse click, right? You can say printer. Okay, you have to say an input device, right? So mouse, you can say a keyboard, and interrupt will be a key press, right? An interrupt will be a key press. Moving on to the next question. The next question says, explain how the processor manages the current program and the interrupt, right? So first you will say an ISR, interrupt service routine, or ISH, right? Interrupt service handler will give or will check the priority of the interrupt and place it into a queue. Right, so first the interrupts priority will be checked. It will be placed into a queue, right? So there will be interrupt 1, 2, 3, 4, 5. So the interrupt that requires a lot of attention will be placed on top. Interrupt which doesn't require a lot of attention will be placed at the bottom, right? Then processor before starting with a new fetch decode execute cycle, it will check the priority. It will solve the first interrupt, right? If the interrupt is not important, like the fifth one, it will skip it, right? It will do it once the fetch decode execute cycle for a process is complete. So this is what we need to explain here and use the technical terms, right? So this is the first point, right? Processor checks interrupt queue before starting a fetch decode execute cycle. Right? Then you will say if interrupt is of higher priority, then the processor will store current processes. Store current process and service the interrupt right? Then you are going to say if interrupt is not a high priority, processor continues with the next fetch decode execute cycle, right? Then the last point you are going to say that the process will repeat. if another high priority interrupt is found. Moving on to the next question. The next question says, draw and annotate a diagram to show the processes from the user entering URL to web browser. So we need to show the web page retrieval process. We need to show the web page retrieval process. So how will we do that? First, you will draw a student's computer because the student is trying to access. So student's computer. Once you draw student's computer, you will say that the student requests a URL. So the student types the URL in the address bar, right? Then this is sent to the DNS. This is sent to the DNS. DNS will find the IP address of the URL. Right, it will find the IP address of the URL. Once the IP address is found, it will return it. Right, it will return it. If you will, then you are going to say DNS2 if 3 if IP not found, a higher authorized DNS will be used. Right, if it finds, it will return it to the DNS1 and then DNS is going to return it to the computer. Once that's done, right, fifth process will be request to web server for SSL certificate. Right, there will be request to the web server for the SSL certificate, right? Then it will send the SSL certificate to computer, right? Once verified, the HTML page will be rendered. Right, this is the way you need to attempt this questions. Okay, moving on to the next question. Next question says, okay, we need to fill the blanks. It's a fill up question. A digital currency does not exist physically, right? So digital currency does not exist physically. So without looking at the options, I will first think what it should be, right? Then I will look at if the options, if it has it. So physically is done. It can only be accessed electronically. Some digital currency have digital ledgers called called blockchains, not miners, digital ledgers, right? So they're called blockchains. Then there are decentralized databases where each transaction is stored as a new set of data with a dash, with a timestamp. Transactions cannot be altered, only new transaction, which allows the location of the data to be retrieved or to be traced. Right, because the history is maintained, so it can be traced. Give one another reason a self-driving tractor is an example of a robot. So one reason they have given is that it has wheels, engine and a framework, which means they are referring to that it has power or the ability to move. So what could be another reason that it is a robot? Because it is programmable. Right. Next question says, if a person is detected within 3 meters while the tractor is moving, the self-driving tractor must stop. Explain how the infrared sensor microprocessor will detect if a person is within 3 meters and stop the tractor if needed. So first, sensor continuously senses data and sends it to microprocessor. Right, it sends it to microprocessor. Then microprocessor compares it to a preset value. which in this case is 3 meters, right? Which in this case is 3 meters. If data is greater than, it is less than 3 meters, a signal will be sent to the actuators to apply the brakes. Right? The whole process will repeat in a loop. The whole process will repeat in a loop. Right? Okay. Next question says identify one other sensor that the self-driving tractor could have. So you need to mention another sensor that the self-driving tractor could have. So you can say proximity sensor. Right? What will proximity sensor will do? It will detect obstacles. To detect obstacles. The similar job to what infrared sensor does. Now the next question says explain the drawbacks of a farmer using a self-driving tractor to sow seeds and harvest crops. So first you will write setup. Obviously if the person is using automatic machines, automatic self-driving tractor, it could be the cost will be higher. So you will say setup and maintenance costs will be higher. You will say setup and maintenance costs will be higher. Then you're going to say that farmer may need reskilling to use it. Right? Obviously the farmer would need the technical expertise to use the self-driving tractor. Right? Then this will lead to layoffs, or it will lead to de-skilling of workers. Right? So it will either lead to farmer, right? The farmer, the main person who is of whose the farm is, he will either do layoffs, right? Fire people, or they will de-skill workers, because of workers, if self-driving tractor comes, the degree value or the skills, the value of the skills of the workers will get depreciated. So de-skilling of workers, right? Okay, identify 3 components of an expert system. So any 3 components could be knowledge base, user interface, right? It could be inference engine. You can also write rule base, right? If there was an option, you could have also written a rule base. Okay, now describe the role of self-driving tractor in the farmer's computer in echo check. So here they're asking us to describe the process of echo check. So let's see how to write the process of echo check. Right? So first point. So okay, how does echo check work? Right? So here is the sender, here is the receiver. So sender is going to send the file to the receiver, then the receiver is going to send the file back to the sender. Sender is going to match the original file with the received file. If there is no errors, or if there is no errors found, then the file has been transferred correctly. If not, then the file has to be resent to the receiver through the sender. So first step, you are going to write that the same data is transferred back from computer to tractor right? Then the tractor compares both sets of data, right? Then if there are no errors, file has been sent correctly. Then tractor sends an affirmative confirmation, right? Okay, now we have question of parity block. So we need to find the parity byte, right? What are they using? Okay, so they're using 7-bit with an odd parity. They're using 7-bit with an odd parity. So complete the parity byte for the data. We need to complete the parity byte for the data. Okay, 1 2 3 4, right? So this makes it an even parity, but we need to make it an odd parity, so we'll add a 1, so it becomes 5, an odd parity. 1 2 3 4 5, right? So we'll put a 0 to make it an odd parity, right? So it remains an odd number. 1 again 0, 1 again 0, 1 2 3 4, here we are going to put a 1. 1 2 3 4 5 0, 1 2 3 4 1, 1 2 3 0, right? So this is how you're going to attempt this question. Now the next question says state the purpose of encrypting data, right? If hacked, or a better word would be intercepted, the data is of no use as it is scrambled to ciphertext, right? Describe the differences between symmetric and asymmetric encryption, right? So for symmetric, right, firstly for symmetric the same key is used. For asymmetric we have a private key and a public key. So for symmetric, you write symmetric uses same key, right? Same key which is shared between sender and receiver. The same key encrypts and decrypts data. The same key encrypts and decrypts data. Now for asymmetric you will write, whereas asymmetric has different keys, right? You can also write if they are public and there's a private key, like you can also write it in that way. Then you will say that the public key encrypts data and private key decrypts data, and private key decrypts data. Okay, the data is using packet switching. Identify any two items of the data contained in the packet header. So the packet header contains sender's IP address, receiver's IP address, or you can also write destination IP address, right? Or you can here also write originator's IP address, right? All will be accepted. If there were more options given to us, you could also write the sequence number of packets, right? Okay, give the purpose of a router in the packet switching process, right? So what is the one purpose of router, right? So since it's a 1 marker question, we need to talk about one purpose of router. So you can say control the best possible route of the packet. Control the route of the packet and ensure the best possible route. Right. Okay. Then it says convert the number 2336 denary number into hexadecimal. So first 236 we need to convert it to binary. 236 2, we need to convert it to binary. So 236 divided by 2 is going to give you 118, so the remainder is 0. 2, again 118 divided by 2 will give you 59, the remainder is 0. Again 58 divided by 2 will give you 29, but then the remainder has to be 1. Then 2 1s are 2, 2 4s are 8, remainder is again 1, 2 7s are 14, remainder is 0, 2 3s are 6, remainder is 1, 2 1s are 2, remainder is again 1. So we'll move this ways. We have the number to be, binary number to be 1110 1100. So 1 2 3 4 5 6 7 8, right? To hexadecimal, so 8421 8421, 9 10 11 12 13 13. So A is 10, B is 11, C is 12 and D is 13, right? E is 14. So 9 10 11 12 13 14, so this is going to be E, right? 8 plus 4 plus 2 is 14, so this is going to be E. Then 9 10 11 12, this is 12, so it's 12 is C, so this is going to be C. So the correct answer is E C, or you can simply write it to be EC, right? Give one benefit of using hexadecimal instead of binary to represent data. You can say easier to comprehend for humans, or you can also say it consumes less storage, consumes less screen space or on screen space, right? Now convert the 2 complement integer, 2's complement integer, right? 1 1 1 0 1 0 1 1 0 1 1 1 into denary. So we need to convert this into denary, right? So first step will be to flip the number. So when we flip the number, we have 0 1 0 0 1 0 0 0. Then we add a 1. Then when we add a 1, we have 0 1 0 0 1 0 0 1, right? Once this is done, you need to convert it to denary, right? So let's convert it to denary. So 1 2 4 8 16 32 64. So when you add 64 plus 8 plus 1, you will get the answer to be 73. So our final answer is minus 73. Give the denary number 45 into 8 bits 2's complement integer. So 45 we need to give into 8 bits 2's complement integer. So once you convert 45 to binary, so let's convert 45 to binary. 2 2s are 4, 2s are 4, 1, 2 11s are 0, 2 5s are 10, 1, 2 2s are 4, 1, 2 1s are 2, 0. So this is going to give us 1 0 1 1 0 1 1 0 1 1 0 1 1 0 1 1 0 1. So 1 2 3 4 5 6 7 8. When we flip the number, we get 1 1 0 1 0 0 1 0. When we add a number, we get 1 1 0 0 1 0 1 1. When you will convert, okay, so this is the answer, right? Okay. Logical shifts are performed by the binary integer. State the mathematical effect of a right shift of 4 places. So we know that there are 2 types of logical shifts, right? We have a left shift and we have a right shift, right? Left shift we multiply it by 2 raised to the power n, and n is the number of shifts we have done, right? And n is the number of shifts we have done. For right shift we divide the number by 2 raised to the power n. N is the number of shifts we have done. So here we are dividing. Since it's a right shift, we are dividing the number by what? By 2 raised to the power 4, right? It will be divided by 2 raised to the power 4 because 4 places are being shifted and n is the number of places, right? So this is all for today. I hope you have understood this paper very well, right? In the next video, we're going to do the next paper. Thank you everyone for watching. Please subscribe and like and share.